Assalamualaikum and a very good morning. My name is Mohamad Syazrin Haikal bin Sakhri, metric number 07DTK22F1011, followed by my friend Irfan Izwan bin Iskandar, Alif Azrai Farhamie bin Mohamad Khadapi, Mohamad and Mohamad Hakimie bin Hashim. We are from Group 1 and this is presentation Mathematics 2, course code DBM20023 with the topic of advanced differentiation. Advanced differentiation is used to solve maximum and minimum problem. Thus, we're going to explain step by step of how to solve this problem. On top is the table of differentiation nature, where it shows us if the second derivative is less than 0, it will form set phase, where the stationary point will be at the top and it will be called maximum point. If the second derivative is more than 0, it will form a happy phase and the stationary point will be at the bottom and it will be called minimum point. And if the second derivative is equal to 0, it will form the inflection point. There are 3 steps of how to solve the problem. Step 1 is to differentiate the given equation to find its stationary point. And step 2 is to do the second differentiation to the first derivative to find the nature of the stationary point. And the step 3 is to sketch the graph.
Assalamualaikum and salam sejahtera. My name is Irfan Izwan bin Iskandar, matrix number 07DTK22F1003. So right now, I will explain step 1 for this question. Firstly, we need to expand the equation before differentiate it. Then after expanding it, we will get y equal to 3x cubed plus 5x squared minus 2. Secondly, we differentiate the equation and we get dy dx equal to 9x squared plus 10x minus 2. Thirdly, when dy dx equal to 0, we will get 2x values, which is x1 equal to minus 5 plus square root 43 divided by 9 and x2 equal to negative 5 minus square root 43 divided by 9. After that, substitute the x values into the equation to obtain the y values. Thus, the y1 equal to 520 minus 80 square root 43 divided by 243 and y2 equal to 520 plus 86 square root 43 divided by 243. Therefore, there are 2 stationary points, which is x1, y1 and x2, y2.
Hello to everybody that is watching this video. Right now I'm going to continue my friend's presentation, or our as a team presentation. Right now I'm going to explain to you about the second step of finding the maximum and the minimum using the equation that was given. Alright, firstly, let's look at this. This is the equation that we get from the first step, and we're going to use it to find the second equation, this one, to use it to find the maximum and the minimum point. So first we need to use this one, the second differentiation. Yeah, it's the second one. The formula is d power by 2 y over dx power by 2 equal to this one, and this one. We're using this equation. All of them are composite rules, so we're going to use composite rule, yeah, to simplify them. Yeah, we're going to use composite rule to simplify them, all of them. So after we simplify all of them, we're going to get this one, that equation, and we're going to use that equation here. Firstly, when x1 equal to negative 5 plus square root of 43 over 9, this we get from the first step, also, and we're going to use it. We're going to put this one on the x, this x. So 18 multiplied by this number plus 10, you will get 13.11. That is a positive x. So just like this is x-axis, this is y-axis. Positive x must be on top of here. Alright, let's move to the second one. This one we also use the same thing, but now we're going to find the x2. x2 equal to -5 minus square root of 43 over 9. This also we get from the first step, and then we're going to put it here, just like over here we put it on the x. 18 multiplied by that number plus 10, you will get negative 13.11. That is, if you use the logic of graph, x-axis, y-axis, it will be down here. That's all what I'm going to tell you guys. For the second step, my friend will explain to you guys how this and this will affect the graph, how those results will affect the entire graph. Alright, that's all from me. Goodbye. Bye.
Thank you, Alif and Irfan. Assalamualaikum and hi. My name is Mohamad bin Hashim, number matric 07DTK 22F1007. Okay, now I will explain about step 3 of this question. First, draw graph by using x-axis and y-axis to the plot of the stationary point that we have got from the step 1 earlier, which is for the stationary point 1, -5 plus square root 43 divided by 9 for x-axis, while negative 0.18 for y-axis, and stationary point 2, -5 minus square root 43 divided by 9 for x-axis, while for y-axis 4.46. Then connect all the plot that we have done on the graph. From the plot that we have connected, we know that stationary point 1 is the minimum point in the graph. It will shape like the letter U, while for the stationary 2, it is the maximum point in the graph. It will shape like the letter N. Stationary point 1 will be on quadrant 4, while stationary point 2 will be on quadrant 2. That's why it will form like the graph above. Based on the graph, we can see that there are 3 intercepts on the x-axis. We need to find the value of the x-intercept. The way is when y equal to 0, then 0 equal to 3x cubed plus 5x squared minus 2x. By using a scientific calculator as above, the value of x that we get is for x1, 1 divided by 3, for x2 is -2, and x3 is 0. That's all from group 1 who presented about question 5. I want to tell you guys about one quote. Somewhere, something incredible is waiting to be known. Thank you for watching.